Hello, today we are going to talk about derivatives and differentiation. So, in middle school, we have learned about the thing rise over run, and this is a way to find the slopes of straight lines and could be rewritten as y2 minus y1 over x2 minus x1. In differentiation and derivatives, we try to find the slope of an equation we receive. And there are ways to do this, rules. And you are able to find those rules by using this equation for instantaneous rates. Instantaneous rates are basically rates at a single point or as close to a point as possible, making basically the slope at that point very accurate. And the equation is limit as h goes to 0, f of x plus h minus f of x over h. Now, I'm going to first talk about the power rule, but this is the only rule I am going to explain how it's found by using this equation. So, let's say we have f of x equals x to the power of n. Now, we plug x to the power of n into this equation, and we get limit of h goes to 0, f, actually no, not f, x plus h to the power of n minus x to the power of n over h. Now, this could be rewritten as limit h goes to 0, x to the power of n plus nx n minus to the x to the power of n minus 1, h to the power of 1 plus n times n minus 1 over 2 x n minus 2 h squared dot dot dot. As you can see, there's a pattern. H increases by 1 in its power, and x decreases by 1 on its power. This is basically just having this part of the equation, including the n, expanded out. So you don't really need to memorize this. It's just stuff to know, stuff to learn, new things. N factorial over 1 factorial times this x times h to the power of n minus 1 plus hn. And so this part of the equation is just this x plus h to the power of n expanded out. So we have this minus x to the power of n over here, all over h. So right off the bat, we can see we can cancel out these two. And then we can also divide by h. So limit as h goes to 0 would be n x to the power of n minus 1 plus n that x to the power of n minus 2 times h dot dot dot. Let's just skip this and put plus h to the power of n minus 1. Alright, now since we have this limit as h goes to 0 to begin with, we can plug in 0, since there's no h at the denominator to make this equation invalid. We can plug in h equals 0 in order to cancel out all this, including the stuffs in the dot dot dot, and we get the power rule, which is n x n minus 1. So this is the power rule. It can be used for many ways to find the slopes of an equation. Let's see. Let me find a good one. Let's just do the first one. All right, 6x to the power of 3 minus 9x plus 4. So the power rule is nx n minus 1. So basically what you do is you subtract 1 from the exponent, and you take that initial exponent, the n, and you multiply it to the coefficient of x. So in this case, we will take this value and subtract it by 1, and meanwhile, we'll multiply this initial value 3, and or we'll take this initial value 3 and multiply it by 6. So it would be 3 times 6 to x to the power of 3 minus 1. And that would be the derivative of this little part right here. And if we simplify that, that would be 18 x to the 2. And then we can do the same things for the others. So this would disappear, and it will be minus 9, because this is x to the power of 1. And because we have x to the power of 0 over here, nothing comes out of this part of the equation. So we get 18x squared minus 9. So that's the power rule. Now let's talk about the product rule. So basically, the product rule is if you have things that are multiplied together. That's the name, product rule. So let's say you have 6x times, I don't know, 3x, let's say. Basically, the product rule is taking one side, so let's say 6x, untouched, while the other side is derived, and you multiply those two values together. So 6x times 3. I got 3 by using the power rule, x to the power of 1. And then you add the other side that's not derived times the other side that wasn't derived is now derived, so times 6. And this will be 18x plus 18x and 36x. As you can see, if you were to use the power rule, 18x squared equals 18x squared, you would still get the same answer as this one. They're the same values. So now let's talk about the quotient rule. The quotient rule is basically the denominator, let's just say p, times the numerator, let's say q, derived. The apostrophe is a symbol of derivation, minus the numerator times the denominator that's derived over the denominator squared. Alright, let's use this rule on this equation. 1 minus x over 1 plus x. So this would be 1 plus x. Let me write it down here. 1 plus x times the derivative of the numerator, which is negative 1, minus the numerator, which is 1 minus x, times the derivative of this bottom value. That would be 1. All over the denominator squared. So that will be 1 plus x squared. And if we simplify it, we get negative 1 minus x minus 1 plus x all over 1 plus x squared. And then we cancel the x, we get negative 2 over 1 plus x squared. And that's the quotient rule. Just memorize all the rules I've said beforehand and learn to apply them to different equations. And you'll eventually just be able to do any equation with these rules in mind without having to go back and memorize these rules again. Let's talk about the last rule, I believe, and that would be the chain rule. So, chain rule. Alright, let's say there is a sine of x. In order to basically derive this, you would first derive the outside portion, and then you derive the inside portion. So let me show you what that is. The derivation of sine of x is cosine, by the way. I'm not going to go through the trig derivations or log derivations in this video. So this would be cosine x times basically this inside value, derived 1, times 1, and that would be cosine x. So let's say you had sine of x squared plus x cubed minus 1. You would first do the outside portion, which is the sine. So that would be cosine x squared plus x cubed minus 1. And you would multiply this with the derivation of the inside, which is 2x plus 3x squared. And there you have it. That is the slope of this equation. And that's the chain rule. And I think all of the rules, excluding the derivations of trig and log rules.